Okay, so we're going to start applying some of the stuff that we've been learning. We're given a bunch of numbers. I have 0, negative 83, pi, 5/9, square root of 17, negative 11/13, 4.7, negative 62, 44/3, and negative 3.5. We want to figure out which ones are whole numbers, which ones are rational numbers, and we'll talk about each of these definitions here in a moment. What are integers and what are irrational numbers? And I want to kind of walk us through that. Next thing we're going to do after this video is we're going to talk about how to deal with fractions when we're multiplying and dividing them. All right, so for our whole numbers, we're going to have anything that is not a fraction at the moment, and anything that is not a have a decimal attached to it. Okay, so that's kind of the easiest way to think about whole numbers. Remember, whole numbers are positive, and they include 0, and they go up by ones. So my whole numbers here, I have 0, and negative 83 is not, pi is not, 5/9, that's a fraction, so I can't put it in that. Negative, or square root of 17, that is not, right? We don't have any number that factors nicely to 17 when you take the square root of it. Closest we have would be 16. And so we've got this 16, well, 4 plus something, right? That's not going to work. It's got a decimal part to it. Negative 11/13, again, that's a fraction. I've got 4.7. That's going to give me a, that has a decimal attached to it. Negative 62. Now, remember, we were looking for positive numbers, so negative 62 is completely out of the way. 44/3, that doesn't reduce nicely, so that also is not included. And then negative 3.5, that has a decimal part, so that is not included in that. So the only whole number we have in this particular group of numbers is 0. Now let's talk about rational numbers. All right, and I'm not sure if I can make this work quite the way. Let's see here if I can make the here. Well, let's see if we can do this. My rational numbers, those are going to be numbers that I can write completely as a fraction. Right? If I were to write it as a fraction, I'm not going to have any decimal parts. I'm not going to have it go on forever with different numbers. I'm not going to have it, you know, just kind of be random numbers. It needs to have a pattern that's exact and exactly repeating. And we'll talk a little bit more about that as we go. All right. So, rational number. We have a rational number of 0, right? That can be written as 0 over whatever number. I have a negative 83, right? Because I can write negative 83 over 1. And that's complete. There's no decimal part to it, right? Pi is not rational, right? Goes on forever and ever, doesn't repeat, never ends. Yeah, that's not rational. I have 5/9. That is clearly written as a fraction. I have square root of 17. That's not rational. We've already talked about the fact that that ending value goes on forever after 4 point something, right? So that's going to be irrational, not rational. My negative 11/13. And rational number here, I've got a 4.7. If you prefer to think about it like this would be a 47/10, right? That's clearly written as a fraction. That works. If you have another thing to know is that if you have a decimal that terminates, like this ends at 7, right? It doesn't go on forever, and it's definitely going to be a rational number. Okay? If it goes on forever and it's the same number or a pattern that's exact, that is also a rational number. All right, so negative 62, 44 over 3, right? That's definitely a fraction. And then my negative 3.5, right? Negative 3.5, right? That decimal terminates, right? It stops. So that right there is also a rational number. All right, in this case, we're next going to look at integers and then irrational numbers. So our integers are pretty straightforward. Remember, that's anything that's a whole number or its opposites, right? So I have 0, I have my negative 83, I have negative 62, and I think that's it. I don't think I had any other integers. Nope, that's it. So our integers are, as I say, anything that's a whole number or its opposite. It's going to have a negative value, or it's from 0 going up by 1. All right, so our irrational numbers, and this is kind of a cool one, but it's also once you understand it, it's pretty easy to tell whether something's irrational or not. In this particular case, we've got pi, which is irrational, right? Goes on forever and ever, never ends, never repeats in any kind of pattern that we can find. They're taking it out to several million decimal places, and still it's irrational. All right, and then we have square root of 17. That was our other irrational number here. So ways that you can tell if something is irrational. If you cannot write it completely as a fraction, by definition, it's irrational. All right, so the numbers that, for our purposes, you're going to have, pi is one of them. There's another number called e, which we use in compounding interest and so on. And then there's anything that's the square root of a number that's not a perfect square. So square root of 2, square root of 3. We would not say 4, because square root of 4, because that's going to give you just a 2, right? So that's a perfect square. Next would be our square root of 5, our square root of 6, our square root of 7, our square root of 8, and then, of course, square root of 9. Our square root of 9 is 3 times 3. So that would not be included as an irrational number. So for our purposes, the only numbers you really need to be concerned with are pi, e, anything that's not a perfect square, that's under a square root, and you should be able to go with that.